The objective of this lesson is a task to find multiple dimensions when given the volume of a rectangular prism. In previous lessons, students have written situational equations to find the volume of rectangular prisms. Students can write these equations in two ways, by multiplying the length by the width by the height, or by multiplying the area of the base by the height of the prism. We can begin by using linking cubes to construct a prism with a volume of 12 cubes. One way to construct this prism is by linking 12 cubes in a row. The dimensions of this rectangular prism can be written as 12 cubes in length by 1 cube wide by 1 cube high equals a volume of 12 cubes. Another way to represent this prism is by placing two lines of 6 cubes side by side. The dimensions of this rectangular prism can be written as 6 by 2 by 1 equals 12, or 12 times 1 equals 12. Placing two rows of 3 cubes side by side and then stacking another layer on top of this base layer creates another rectangular prism with a volume of 12 cubes. The dimensions of this prism can be written as 3 by 2 by 2 equals 12, or 6 times 2 equals 12. Placing two rows of 2 cubes side by side and then stacking 3 more layers of cubes on top of the base is another way to create a prism with a volume of 12 cubic units. These are just a few ways that a rectangular prism with a volume of 12 cubes can be constructed. Children can use the cubes to create other prisms that have a volume of 12 cubic units. The following questions can be asked to help deepen students' understandings. What does each equation have in common? Why does each equation have the same product and volume? What do the equations with 2 factors represent? What do the equations with 3 factors represent? The objective for this lesson was to find multiple dimensions of a rectangular prism when the volume was given. We met this objective by making models of rectangular prisms with the same volume and then writing situational equations to represent the dimensions of each prism.